We are at Avid Extreme Sports Park in Guthrie, Oklahoma, one of the premier paintball facilities in the state. They are doing an expansion and need accurate contours so they can plan and execute successfully. With our LiDAR, we can give them the data that they need. One of Blue Falcon Aerial's owners, Michael, has been playing paintball here for many years, and Avid owner Trey has agreed to let us use his field. We are really excited for this capture since this location will showcase how well the lasers can pick up all the small details in the buildings as well as penetrate through the thick vegetation canopy. We intend on using this as a cornerstone piece that we can give to potential clients to show off the highly accurate R2A LiDAR sensor and the Rock Cloud system. This is so much more than Trey and his team are ever going to need, and we are going to blow their minds once it is done. Let's knock out this flight so we can get back to the office so I can show you guys exactly what the R2A LiDAR sensor and the Rock Cloud system can do. Welcome back to the office. We are really excited to see how Avid Capture turned out. It's been about 2 weeks since the capture at Avid. There were some other projects that came up that required our immediate attention, so YouTube did have to go on the back burner for a while. However, we are back now and you should be expecting a lot more consistent content from us. Well, this is the moment you guys have been waiting for. Let's go and see how Avid turned out. Let's go. Welcome to the Rock Cloud, guys. The Rock Cloud is a really cool system that was developed by Rock Robotics that you can send your pre-processed data into, order deliverables from their GIS and surveyor experts, as well as deliver the content straight to your client. It is an all-inclusive, all-in-one system that is absolutely game-changing for the industry. The Rock Cloud allows businesses like ours to leverage their experience and their team so they take our raw data and turn it into something the client actually wants. It also allows my team to do what we're really good at: focus on capturing as much data as possible for our clients. Let me show you some of the really cool deliverables that Rock Robotics offers. If you go to our website and click on the deliverables tab at the top, we have an article that's focused on all the Rock Cloud deliverables and what the Rock Cloud can actually do. So as you can see, this is an overview of the Rock Cloud, how you have the contours, how you can use the measurement tools to get area and height and some other cool things. Stockpile analysis feature, which is absolutely game changing. You can go over here to the Rock Surveyor. You have ground only, enhanced classification, enhanced plus. We're actually doing enhanced classification for this video, which is a really cool thing, and I cannot wait to show you guys off on that. We also have additional thing about the contours, accuracy reports, planimetrics, vegetation management, and of course the obstruction report that comes with the vegetation management, which is simply astonishing, and it's an absolute game changer. All right, so here we are back to the Rock Cloud. As you guys can see, I only have a trial edition. It's simply because Nick does all of our processing. He is our tech guy for the team, so he makes sure the data is inputted correctly and we get an actual deliverable that can go to the client. So for this, I just have a trial account so we can just show the data on here. So we're going to go over here to share projects. Once we go to share projects, these are the Rock Robotic demo projects. However, I actually have our demo projects on here. So as you guys can see, we do have 3 captures on here that you can see for yourself. You can see this either in the description of this video, on our website, or you can also go here to Rockstars on the Rock Cloud and you'll be able to sort by our company, Blue Falcon Aerial, and you can also look at any of these. So obviously for this video, we are focusing on Avid paintball captures. So let's go ahead and open it up. All right, so here we are in Avid paintball capture. You can see right here at the top. The first thing you probably notice is that this image is clearly different than the surrounding. This is because we actually did an orthomosaic of this capture as well, and we were able to overlay it in the rock cloud system. Really, really neat feature they have there. This orthomosaic was captured using the Sony A5100 24 megapixel mirrorless camera that is attached to the Rock Robotics R2A sensor. That's quite a tongue twister. That camera is absolutely good enough for whatever sort of orthomosaic you're going to need to capture. However, be aware you actually don't have control over the Sony A5100 while it is in the air. So what that means for you is that make sure that you have plenty of overlap to get enough pictures. Make sure you're going slow enough so you don't overshoot your area, and also make sure that you have plenty of high light so you don't have to worry about your exposure. So what that means for us is that if we absolutely do need that orthomosaic done at the same time as the LiDAR data, what we'll do is we'll put a Mavic 3 Enterprise, or we'll put up a Phantom 4 RTK and put it up there so we actually can adjust the exact overlap amount as well as the exposure level. So all of that being said, let's go ahead and see how did the Sony A5100 do on this orthomosaic. Let's zoom in and see how well it looks. All right, let's let this sucker load. Oh, okay. Wow, look at this, guys. You can see these barrels perfectly. Oh, fantastic. Okay. Awesome. Oh, wait. Okay, and look at our GCPs. Oh, look at this, guys. Our GCP, perfect. Absolutely perfect in the center. Gorgeous. Gorgeous, gorgeous. Okay, so as we can see, just because the R2A may not be the most optimal camera to use for an orthomosaic, it is certainly good enough for most of your clients on what they're going to be looking for. Look at this right here. That is just fantastic. Okay, awesome. This flight was done at 60 meters, to give you an idea. So around 185 feet, give or take. And you can see this is definitely very, very good quality. All right, so while we're here, let's check on the left-hand side. As you can see, this was approximately 50 acres. We captured a lot more, but we went ahead and cut off a lot on the outside. One of the main reasons is because Rock Robotics charges by the acreage amount. So it was something like 85 acres with all the extra LiDAR that was captured. So we trimmed it all down to get our acreage as small as possible. No reason to really process data when it's not needed by the client. It just costs extra money and wastes Rock Robotics time. All right, so something else you can notice over here is the coordinate reference system. We captured in WGS84 UTM zone 14 north, and we also captured an ellipsoidal. However, we did reproject it over here to NAD83, and for vertical into NAVD 88. All right, so this was done post-processing. Just be aware, you do have a lot of flexibility on exactly how you're going to project your coordinate systems on here. So when you've already pre-processed and colorized your data and you have your LAS file, it's actually surprisingly easy to import it into the Rock Cloud. If you go over here to Manage Project, this is exactly how you do it. They go step by step, and it's a really simple process. Now, I will say, capturing and pre-processing is quite challenging. However, once you figure that out, the cloud side of it is surprisingly simple. So over here on the deliverables section, you can see we do have our uploaded deliverables. This is the orthomosaic that we generated off of Pix4D, and we geo-referenced all of our GCPs, and it generated out a really nice GeoTIFF file that imported straight into the Rock Cloud with no issues whatsoever. And like I showed you guys, this is perfect. This is absolutely gorgeous. It transferred over without any problem whatsoever. Now, as far as what Rock Cloud gave us, we have our contours that you can export here. You also have your digital elevation model in a TIFF file, as well as an accuracy report that we'll go over very soon. Very, very neat, and it's all in one place, and our clients have absolutely loved this system. All right, so the last thing I'm going to show you guys on the orthomosaic side of this, you have a few different things that you can do on the right-hand side as well. You have different measurements that you can use. You also have different layers to include your contours. You can add contours straight here on the orthomosaic. Now, the orthomosaic did not generate these contours. That was done by the LiDAR data itself. However, having this orthomosaic generated right over the orthomosaic is actually a really cool feature, and we really do like it. Another cool thing about the Rock Robotics system is you can just click right here and it will take away or add the GeoTIFF itself, orthomosaic, and you can see the quality. Let's take this off real quick. You can see the quality difference is phenomenal. It's not even close. So the Google map, this is the Orthomosaic itself. So Orthomosaic, Google map, Orthomosaic, Google map. It's just incredibly cool on how this worked. All right, so now let's transition over to the LiDAR side. And here's the LiDAR data. And as you can see, this is just gorgeous, guys. Absolutely gorgeous. As you probably know, the R2A, it does have 250,000 pulses per second that it sends out. That is just an astonishingly high number of points, especially for a flight that took around 45 minutes. So each second, 250,000, and you're flying it for 45 minutes. Like, that's just an astonishing number of actual points that hit the ground, bounce up, and all those measurements being taken into account. It's incredible, guys. Absolutely incredible. All right, so the first thing we're going to do here is we're going to go right over here to the layers section. I don't like watching it in the intensity gradient. Instead, I like looking at it in RGB because, you know, I like to see pretty colors. And here it is. This is what the actual data looks when it's colorized. And the colorization part happens during your pre-processing. And it's a really neat system, and all of this is done by using the Sony A5100 data and overlapping it with the LiDAR data. And it does it essentially automatically when using GC Painter, and it's a really cool system. All right, so as we scroll around, we can see that it keeps rendering more and more data as you move. My computer's fairly fast, but there's just so much data on here that it's not going to render everything it needs without sitting for a very long period of time. So let's start looking around and try and identify some things. So right here, you can sort of see it. This is our tripod, our MLID RS2 Plus right here on top. And then we have one of our GCPs. Looks like it's a little bit off, but not too bad. Then let's go over here. Let's check out this one. Pretty close as well. Right there. Not bad either. Where's some other ones at? Here's this one. All right. Then right over here. All right, so that you see there's a little bit of variance on here, but we have enough GCPs down. Let's go ahead and check out that accuracy report. I'm really curious to see how accurate was this data. If you go over to deliverables, let's go to accuracy report. This is what it generates, and this is what, anytime you do a rock surveyor, you get this accuracy report. Wow. Okay, so vertical accuracy on this data was 0.02 meters, which would be 2 centimeters. Yeah. So 2.4 centimeters of vertical accuracy in this data set. That's really good, guys. That's really, really good. And I'm very happy with that, honestly. That's a really good accuracy. And point density, like I was telling you about how many points, 856 points per square meter. That means for every square meter of ground that is on that plane, there are 856 measurements that happened with the R2A LiDAR system. That is just phenomenal. Standard delta looks great. Guys, like, this is a really good accuracy. Okay, these are our GCPs. Yeah, and they're all pretty close on the vertical side. Yeah, this looks really, really solid. I'm very happy with this accuracy report. Awesome. All right, so one of the really cool things about LiDAR is how it's able to penetrate through the vegetation canopy on a project, right? And I have more information on our website. If you go over here to the aerial LiDAR section, and a little bit of blurb of how it does it, some examples of what it looks like, and of course the video that Harrison from Rock Robotics did put out that explained a lot more detail on how that works. Really, really cool process. But all you have to do when you get this data to remove vegetation is go over here to Layers, Classification, and click this button right here, Show Ground Only. Pop. All our vegetation has now been removed, and all we're left with is the bare earth level of the ground. This is simply astonishing on how it can do this. All right, here it is. Now it's all gone. Simply amazing, guys. And like, the value that this adds and brings to surveyors when they're trying to go through dense vegetation is it's incredible. It's absolutely incredible, and it provides tremendous value for them. So now that you've removed all the vegetation, another cool thing you can do is push right here, and it shows the surface. It creates a model of just the bare earth with all the vegetation removed. And then from this bare earth model, it can then start adding contours to it. So there's a low, there's a medium, and there's a high, and there you go. Now, we did not get that much detail and that much, our interval was actually quite high for this particular project, but some of our other ones, we did very, very tight intervals, and make sure to check them out, and you'll be able to see how much detail you can get from these contours. So high on this one's not that impressive, but still, it's definitely here. All right, so the next thing I'm going to show you guys, let's take off the surface again. Now, this is the reason why we paid for that additional service on the Rock Cloud. This is the enhanced version of the Rock Cloud, and we did this so we can do this right here. If we want to just have the vegetation, we can click right here, and only vegetation appears. Pretty neat, right? You can also get rid of the ground earth, and you can see only where the vegetation is at. So let's put the ground earth back on. Let's get rid of the vegetation. And now we can go to only buildings. There's only the buildings and only the structures that are on this project. Absolutely. It's so cool, guys. Like, this is so cool. Other things you can do as well is the wires for our power line right over here. So there's just the wires, and I believe this one, yep, perfect. There's the transmission tower as well. So transmission tower, there's the wire. You want to get one of one, get rid of one. Here it is. You want to bring it back. There it is. You want to get rid of the transmission towers. There it's gone. This is so cool. Now, for your own project, you don't necessarily need all these additional classifications. We wanted it for this one just so that we can have an example data set to show how this process works. But if you do the basic level, you're still going to get vegetation and ground, which is usually plenty for what you're going to need for your clients. So there's the ground, it's removed. There it is, high vegetation. There it is. Like, this is how it works, guys. Really, really simple, really cool. It's really neat. That's really, yeah, really cool. Now, I can spend a lot longer talking about all the other features that exist on the Rock Cloud, and I probably will in future videos, but there is one more thing I have to show you before I leave, because this next one is an absolute game changer. If you are a land developer and you have to ship in dirt to fill holes on your property, or you have an excess amount of dirt and need to ship it off a property, you do not want to go anywhere. This is the stockpile analysis tool on the Rock Cloud system. Just watch. It will blow your mind. All you're going to do, click Add Stockpile Analysis, and you are simply going to trace around the area you want to calculate. Now, the more lines you put in there, the more detail you're going to get. However, for this, we're going to get a general estimation. Click there, go here, click Calculate. Inside of this stockpile, there is 63.226 meters cubed of volume. That is simply how easy this is. Absolutely game changer. And if you deal with dirt, if you're a land developer, you already know the value. No one has to convince you. This is a game changer, and you know it. So, like I said, I'm not going to go too much on the weeds in this video. There is a lot more that can be done. If you do want to check this out more, make sure to check out this measurements tab. It offers a lot of really cool things that you can do. Be aware that this is done on a 3D plane, not a 2D, which makes it a little bit harder to try to utilize. It's not wrong by any means. It's just you have to understand you're working in three-dimensional space with a lot of these tools. Well, that's basically what we got for this video, guys. In the comments below, let us know if you like this sort of content. Is this a video that you found of value to you? If not, why not? And maybe there's something that we may have missed, or maybe you do like this content and you want to see more of it. Either way, let us know. Tell us what we're doing right. Tell us what we're doing wrong. And also tell us what you guys want to see next in future videos. So as you can see right here, this is a truck. This is the truck that I actually talked about in my video where I showcase my Toyota SR5 and go into a lot of details on exactly what is in that vehicle and what makes it capable of being able to travel across the country as a professional drone pilot vehicle. So outside of that, I'll let you guys go. Have a good one, and I'll see you in the next one. Bye, guys.